This is the last video for 5.2, and I'm just going to go through the answers to some of the exam questions. The first question, you're asked what is meant by the term ionic lattice. For 2 marks, you need to say repeating pattern of oppositely charged ions. In the mark scheme at the back, it says that this phrase, repeating pattern, was commonly omitted. Okay, so please make sure you mention repeating pattern and then of oppositely charged ions. Instead of oppositely charged, you could have written between positive and negative ions. And also because they've mentioned aluminium fluoride, you could specifically talk about aluminium and fluoride ions. Underneath, they ask you to draw a dot and cross diagram for aluminium fluoride. Okay, so aluminium's in group 3. It loses 3 electrons. So I've drawn aluminium without any electrons and with a +3 charge. I've drawn 3 fluorine ions. Each fluorine ion, okay, it's in group 7, so it's got 7 of its own electrons. So I've drawn 7 dots, and I've drawn 1 cross to represent the extra electron it has gotten from aluminium. I've drawn 3 fluoride ions. They each have a negative charge. So I've got +3 in total, and I've got 3 -1s. The next question, what is meant by an ionic bond? Electrostatic attraction between oppositely charged ions. On the mark scheme, it said a lot of people forgot the phrase electrostatic attraction. This is your definition for an ionic bond. It's the only thing that's going to get you that mark. Then you're asked to draw a dot cross for barium oxide, okay? Barium's in group 2. It's going to lose 2 electrons, so I'm drawing it without any electrons, and I'm drawing it with a +2 charge. Oxygen's in group 6. It's got 6 of its own electrons, which I've represented with crosses, and I've drawn 2 dots to show the electrons that it has gotten from barium. Because it's got 2 new electrons, I'm drawing it with a -2 charge. The next question is a calculation, okay? You're asked to calculate the number of barium ions in 1.5 grams of barium oxide, okay? You're given a mass, so even if you're not entirely sure what to do in this question, if you're given a mass, just find moles, okay? Always find moles. It's typically where you're going to get your first mark. So the mass of barium oxide, you're told, is 1.5 grams. I can work out the formula mass of barium oxide using the mass numbers from my periodic table, and that works out as 153.3. To find moles, moles is mass divided by formula mass, which is 1.5 divided by 153.3, which is this number here. Notice that I didn't round this number. I kept it as long as possible so that my answer was going to be accurate. Okay, this is the amount of moles. This gets you 1 mark, but they're asking you for the number of ions. Okay, anytime you're asked to calculate the number of molecules, the number of ions, the number of atoms, anything like that, they're asking you for the number of particles. That's when you're using Avogadro's number, which is 6.02 by 10 to the 23. You're not given this number, you are expected to know it. Okay, it'd be like the equivalent if I told you you had 12 dozen donuts, and I wanted to know how many individual donuts you have. Okay, you know that a dozen is a word that represents the number 12. You've got 12 dozen, so you've got 12 times 12, you've got 144 donuts. Okay, this is the amount of moles that you've got in this question. You know that the word mole represents the number 6.02 by 10 to the 23. If you want to know how many ions, in this case, you multiply the number of moles you've got by the number the word mole represents, and you're going to get your number of ions. Okay, it asks for a standard form, okay, so by 10 to the 21, and to 3 significant figures, so I've written it as 5.89. The next question, you're asked for a dot cross diagram, so it's between sodium sulfide. Sodium's in group 1, it loses 1 electron, so I've drawn sodium without any electron with a positive charge. Sulfur is in group 6, I've drawn 6 of its own electrons as dots. It needs to gain 2 electrons, so I've drawn 2 X's to show that it's gotten 2 new electrons. Because getting 2 new electrons, it's got a 2- charge. You're told in the formula that you need 2 sodiums, but hopefully you should be able to spot that anyway. If sulfur needs to gain 2, and sodium's only losing 1, you will need 2 sodium to provide sulfur with the electrons it needs. And you can see you end up with 2 positive charges, 2 negative charges, it all balances out. The next one, okay, you are asked firstly to just write the electron configuration in terms of subshells of an Fe2+ ion. When it says in terms of subshells, okay, it just means that you're not using any types of shortcut. You are writing out your electron configuration in full. It's okay to use the p shortcut and put all the p orbitals together, but you shouldn't be using the noble gas shortcut, okay? When I write it out for iron, okay, I see iron, okay, is all the way over here. Okay, and normally I would write down argon, and then I would have another 8 electrons to assign, and that would be 4s2, 3d6. Because it's a 2 plus ion, it loses those 2 electrons from the 4s orbital, and you're just left with 3d6. You could write 4s0 afterwards if you wanted to, but there's no need to include it. This next one is harder, so I'm going to do this one out for you, and it asks you to draw a dot cross diagram for FeS2. This is where it's really important that you're actually reading the question, okay? It tells you FeS2 is an ionic compound, and it's made of Fe2 plus ions and S2 2 minus ions. So this species here, S2 2 minus, is not anything that we ever would have come across before, okay? It tells you you've got Fe2 plus ions. So I'm going to start off by drawing that because that's the easiest part. So I've got iron. It's lost 2 electrons. So I'm just going to draw it with no electrons and with a +2 charge. When I am drawing my sulfur, my S2 2 minus, okay, that's all. I'm just going to put the 2 S's there for now. That's all one big ion with a 2 minus. This is all one species. We've got 2 sulfurs in there, and it's got a 2 minus charge. I now need to put in my electrons, okay? It's got a 2 minus charge, which tells me it's after gaining 2 electrons, and it's gained these 2 electrons from iron. So I'm going to use a red pen for this. I'm going to draw each sulfur with 1 electron that it's after getting from iron. So iron's lost 2 electrons, one's gone to one sulfur, one's gone to the other sulfur, and I've represented that in red. Okay, that represents the 2 electrons that these sulfurs have gained, which is why I've got an overall 2 minus charge. Okay, sulfur is in group 6, which means it's got 6 of its own electrons. Each sulfur atom is different, so I'm going to use crosses for one sulfur, and I'm going to use dots for the other sulfur. I'm going to start with this. Okay, I've got 6 electrons to draw in for sulfur. 1, 2, 3, 4, 5, 6. Okay, so I've drawn in sulfur's own electrons. The way I've got this drawn here, I've got 2, 4, 6, 7 electrons around sulfur. Okay, we know sulfur likes to have 8 electrons in its outer shell. We also know that these 2 sulfurs are coming together as S2. That tells me that these 2 sulfurs are bonded together. Okay, because they're both non-metals, they're going to be held together by a covalent bond. Okay, so when I'm drawing this sulfur's electrons, okay, again, it's in group 6, so I've got 6 of its own electrons to assign. 1, 2, 3, 4, 5. And I'm going to put the 6th electron there. Okay, that tells me that these 2 sulfurs are forming a covalent bond with each other, which is represented here by the X and the O in between them both. And they've both each received an electron from iron, which is represented by the red dot. This means this sulfur has 2, 4, 6, 8 electrons in total. This one has 2, 4, 6, 8 electrons in total. They have each gained an extra 2 electrons, one through forming a covalent bond with each other, and they've each received 1 electron from iron. That gives the overall S2 at 2 minus charge because they've received 2 electrons, and then it cancels out with a 2 plus charge on iron. Okay, this is an example you wouldn't have come across before, so I don't expect everyone to get that one right. But it is the same as what you'll see with oxygen. Oxygen does the same thing when it forms peroxide ions, and there are more exam questions. It's more common that they ask you about oxygen forming peroxide ions. So it's fine if you didn't get it right this time, but pay attention to this example. It is important because it often gets asked with oxygen instead of sulfur as peroxide ions, and the layout is exactly the same. Okay, and the next question, question 5. Okay, they give you information and then they're asking you down here to tick a box. If I just go through the pieces of information, okay, they both have relatively high melting points. One will conduct electricity when solid, the other won't. They will both conduct electricity when molten, one soluble in water, the other isn't. So I think the easiest piece of data to focus on is this part here. This substance doesn't conduct electricity when solid, but it does when it's molten. That means it must be ionic, okay? We know ionic compounds don't conduct when they're solid, but they do conduct when they're molten. Okay, so I need D to be ionic, so it could be B or it could be D. If I look back at C, I see it does conduct when it's solid and it does conduct when it's molten. If it's conducting when it's a solid, that must mean it is a metal. So it's not going to be giant ionic, it's going to be giant metallic, giant ionic, and your answer is going to be D. The last question, barium chloride is soluble in water. Compare the electrical conductivity of the solid and aqueous barium chloride. Explain your answer, okay? So you're comparing barium chloride's ability to conduct electricity when it's solid and when it's in solution. So I'm going to say it does not conduct electricity when it's solid, and the reason is because the ions are not free to move. It does conduct electricity when it's solution because the ions are mobile, or they are free to move. To get full marks in this, for the first part, you need to say that it doesn't conduct electricity when it is solid. And the reason it doesn't is because those ions aren't moving. For the next bit, you have to say it does conduct when it's solution, and you have to say the ions are moving. The word ions has to be mentioned. You need to say not moving and then are moving in order to get full marks. And that's the end of the exam.